everyone, welcome to grade 9 physics chapter motion. Today we are going to learn about second equation of motion. Second equation of motion. The second equation of motion gives us an equation for find out distance traveled by the body. So we can consider a body having initial velocity u and final velocity v. So here the initial velocity of the body is u, final velocity v, and it's traveling a distance s and traveling with a uniform acceleration a in time t. So here we are going to find out an equation for distance traveled s. Okay. So we can begin the derivation with the equation of average velocity. We know that average velocity is equal to initial velocity plus final velocity divided by 2. So we can write in mathematically u plus v by 2. Also we know that distance traveled is equal to average velocity into time. We get this equation for velocity is equal to distance traveled by time taken. So from that equation we get distance traveled is equal to average velocity into time taken. So now we can write this equation distance traveled, that this average velocity, instead of this average velocity we can write u plus v by 2. So now we get s is equal to u plus v by 2 into t. So this is we can call this equation 1. So from the first equation of motion we have v is equal to u plus at. From this we can write, putting this equation first equation of motion in equation 1, that is in this equation we can put the value of v in this equation. So now we get s is equal to u plus v by 2 into t. This is equation number 1. So we put the value of v in this equation. So we get s is equal to u plus, instead of this v we can write u plus at. So into this t and divided by 2. So when we solve this equation we will get s equal to 2u plus at into t divided by 2, and this is become 2ut plus at square by 2, and so we can write this 2, this 2 and this 2 will cancel, then here become ut plus at square by 2. So this equation will become s is equal to, that is distance traveled is equal to ut plus half at square. This is known as second equation of motion, whereas s is the distance traveled by the body and u is the initial velocity, a is the acceleration. So using this equation we can find out the distance traveled by the body. So now we derive the equation, second equation of motion. So we can try to solve a problem using second equation of motion. So this is a problem for you. The problem is a racing car has a uniform acceleration of 4 meters per second square. What distance will it cover in 10 seconds after the start? So the problem, you can read the problem. So first of all, we can write the given data. In this question, we have initial velocity u is equal to 0, because the racing car has a uniform acceleration is given, and the last sentence 10 seconds after the start. After the start means it was in rest. So the initial velocity is 0. What is this time? Time also given in the question, 10 seconds. Then acceleration a also given 4 meters per second square. So here we have initial velocity, final velocity not given, and s also not given, t given. So we can try to find out distance traveled by this body. So we can put these all values in second equation of motion. That is S equal to ut plus half at square. So we will get u is given in the question. So u is equal to 0. So 0 into 10 seconds. So time is 10 seconds. 0 into 10 plus 1 by 2 into a is 4 into 10 square. It become this side becomes 0. Then this become S is equal to half into 400. 4 into 100 is equal to 400. Then half into 400 is equal to 200 meter. So distance traveled by the car will be 200 meter. Now we find out the distance traveled by the car using the second equation of motion. In the next video, I will come with the third equation of motion and numerical problems. Thank you.